Welcome to our video on theorems and proofs. In this video, we will explore the fascinating world of mathematical theorems and proofs. We will learn what they are, how they are used, and why they are important. So, let's get started. What are theorems? A theorem is a statement that has been proven to be true using logical reasoning and mathematical principles. Theorem is derived from the Greek word theorein, which means to observe or to see. Theorems are used to explain and describe mathematical concepts and relationships. What are proofs? A proof is a logical argument that shows why a theorem is true. Proofs are used to verify the validity of a theorem and to convince others that it is true. Proofs are based on axioms, definitions, and previously proven theorems. Why are theorems and proofs important? Theorems and proofs are important because they form the foundation of mathematics. They provide a rigorous and systematic way of understanding mathematical concepts and relationships. Theorems and proofs are used in various fields, including science, engineering, economics, and computer science. Conclusion. In this segment, we have learned what theorems and proofs are, how they are used, and why they are important. In the next segment, we will explore the different types of theorems and how they are proven. In this segment, we will explore the different types of theorems and how they are proven. Geometric theorems. Geometric theorems are theorems that relate to shapes and their properties. For example, the Pythagorean theorem states that in a right-angle triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. Geometric theorems are often proven using Euclidean geometry, which is based on a set of axioms and definitions. Algebraic theorems. Algebraic theorems are theorems that relate to algebraic equations and expressions. For example, the quadratic formula is a theorem that provides a formula for finding the roots of a quadratic equation. Algebraic theorems are often proven using algebraic manipulation and logical reasoning. Number theory theorems. Number theory theorems are theorems that relate to the properties of numbers. For example, Fermat's last theorem states that there are no three positive integers a, b, and c that satisfy the equation n plus b n equals cn for any integer value of n greater than 2. Number theory theorems are often proven using number theory techniques such as modular arithmetic and prime factorization. Conclusion. In this segment, we have explored the different types of theorems, including geometric theorems, algebraic theorems, and number theory theorems. In the next segment, we will learn about the different methods of proof used to prove theorems. In this segment, we will learn about the different methods of proof used to prove theorems. Direct proof. A direct proof is a method of proof that uses logical reasoning to show that a theorem is true. A direct proof starts with the assumptions or axioms and uses logical steps to arrive at the conclusion. For example, to prove that the sum of two even numbers is even, we can assume that the two numbers are even, and then use logical steps to show that the sum is also even. Indirect proof. An indirect proof is a method of proof that shows that a theorem is true by assuming that it is false and then arriving at a contradiction. For example, to prove that the square root of 2 is rational, we can assume that it is rational and then arrive at a contradiction by showing that this assumption leads to a logical inconsistency. Contrapositive proof. A contrapositive proof is a method of proof that shows that a theorem is true by proving its contrapositive. The contrapositive of a theorem is formed by negating both the hypothesis and the conclusion of the theorem. For example, to prove that if a number is not divisible by 3, then its square is not divisible by 3, we can prove the contrapositive, which is that if the square of a number is divisible by 3, then the number itself is divisible by 3. Conclusion. In this segment, we have learned about the different methods of proof used to prove theorems, including direct proof, indirect proof, and contrapositive proof. In the next segment, we will explore some famous theorems and their proofs. In this segment, we will explore some famous theorems and their proofs. Pythagorean theorem. The Pythagorean theorem is one of the most famous theorems in mathematics. It states that in a right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. The Pythagorean theorem was first proved by the ancient Greek mathematician Pythagoras using geometric methods. Fermat's last theorem. Fermat's last theorem is another famous theorem that states that there are no three positive integers a, b, and c that satisfy the equation n plus b n equals cn for any integer value of n greater than 2. Fermat's last theorem was first proposed by the French mathematician Pierre de Fermat in the 17th century, but it remained unproven for over 350 years. In 1994, the British mathematician Andrew Wiles finally proved Fermat's last theorem using advanced mathematical techniques. Four-color theorem. The four-color theorem is a theorem in graph theory that states that any map can be colored using only four colors in such a way that no two adjacent regions have the same color. The four-color theorem was first conjectured in the 19th century and was finally proved in 1976 by the American mathematicians Kenneth Appel and Wolfgang Hagen using a computer-assisted proof. Conclusion. In this segment, we have explored some famous theorems and their proofs, including the Pythagorean theorem, Fermat's last theorem, and the four-color theorem. In the final segment, we will summarize what we have learned and discuss the importance of theorems and proofs in mathematics and beyond. In this final segment, we will summarize what we have learned and discuss the importance of theorems and proofs in mathematics and beyond. Summary. In this video, we have learned that a theorem is a statement that has been proven to be true using logical reasoning and mathematical principles, and a proof is a logical argument that shows why a theorem is true. We have explored the different types of theorems, including geometric theorems, algebraic theorems, and number theory theorems, and the different methods of proof, including direct proof, indirect proof, and contrapositive proof. We have also looked at some famous theorems and their proofs, including the Pythagorean theorem, Fermat's last theorem, and the four-color theorem. Importance of theorems and proofs. Theorems and proofs are important because they provide a rigorous and systematic way of understanding mathematical concepts and relationships. They form the foundation of mathematics and are used in various fields, including science, engineering, economics, and computer science. Theorems and proofs also teach us valuable skills such as logical reasoning, critical thinking, and problem-solving, which are essential in many aspects of life. Conclusion. In conclusion, theorems and proofs are essential tools in mathematics and beyond. They provide a systematic way of understanding and explaining mathematical concepts and relationships, and they teach us valuable skills that are essential in many aspects of life. We hope that this video has helped you understand the fascinating world of theorems and proofs. Thank you for watching.